Have you ever felt tiny? When you just pause for a moment and look at this infinity we live in, billions of galaxies. Inside each one, billions of stars. Orbiting one of those stars is a pale, ocean blue dot, our home. When faced with this dizzying vastness, you can't help but ask, what is the secret behind this magnificent cosmos? But what if I told you that this entire magnificent structure, this mind-boggling order, is actually part of a principle that transcends even our imagination? This isn't a line from a science fiction movie. This is the very theory, based on physics and mathematics, that one of today's most famous scientists, astrophysicist Neil deGrasse Tyson, has also highlighted, a theory that is simply mind-blowing. Now, set aside all your preconceptions, because for the next 7 minutes, we will pursue this question. Does the universe we live in possess the characteristics of a black hole? To unlock the door to this theory, we must first understand our key, the black hole. Thinking of it as a monster that devours everything is like trying to explain the ocean with a single drop of water. So let's start from the basics. To launch a rocket from Earth, it must overcome the planet's gravity by reaching a specific speed known as escape velocity. Now imagine an object that is so dense and massive, its gravitational pull is too strong for anything to escape, even light itself. The laws of physics state that nothing can travel faster than light, so when an object becomes this extreme, escape is impossible. That is a black hole. We call the boundary where escape becomes impossible the event horizon. Think of it like a boat in a river flowing towards a giant waterfall. At first, the current is slow, and you can still turn back. But as you get closer, the current becomes relentlessly fast. Soon you reach a point of no return, and no matter how hard you row, the current will overcome you. That point of no return is the event horizon. The size of this horizon depends on just one thing: mass. It's a direct relationship. The more mass a black hole has, the wider its event horizon. So if a black hole's mass increases by 10 times, its diameter also grows by 10 times. Let's keep this simple but crucial piece of information in mind, because what we are about to discover about the universe begins right at this point. Now, let's get to that mind-boggling calculation Neil deGrasse Tyson mentioned. Scientists conducted a thought experiment using Einstein's equations and their best estimates of the universe's mass. Their question was this: what if you could take everything in our observable universe, all the galaxies, stars, and gas clouds, and compress it all into a single point? If we were to create a black hole with the total mass of the universe, just how large would its event horizon be? The expectation was a random, unrelated number, but the result sent shockwaves through the scientific community. The size of this hypothetical black hole turned out to be almost exactly the same as the size of our observable universe. Allow me to repeat that. The total mass in our universe precisely matches the mass required to create a black hole that is the size of our universe. A coincidence of this magnitude is almost impossible. It's as if the cosmos itself is trying to tell us something. In science, when the universe presents such an elegant harmony, it's an invitation to look deeper, an invitation to understand a more fundamental truth. This startling connection is the first breadcrumb on the trail, and this is only where the trail begins. Now let's move on to the second and even more mysterious piece of evidence: the universe's rotation. We normally assume the Big Bang started the universe symmetrically, expanding equally in all directions. Imagine throwing 1,000,000 grains of sand into the air. You wouldn't expect them all to spin in the same direction, would you? The universe should be the same. Each galaxy forms from its own unique, randomly churning gas cloud, independent of the others. So, the sum of all those random spins should cancel each other out, resulting in a perfect cosmic equilibrium. However, a recent study has called this balance into question. While examining hundreds of galaxies, scientists noticed a statistically significant trend. Roughly 2/3 of the galaxies they studied were spinning in the opposite direction of our own. It was as if one side of the cosmic scale was ever so slightly heavier. a faint whisper that the entire universe might have an overall rotational motion. So, what does this have to do with black holes? This is the key. A black hole erases almost all information about what falls into it: its color, its shape, its composition. But there are two things the laws of physics say it never forgets: its total mass and its total angular momentum, its spin. If our universe shares the characteristics of a black hole, this overall rotation could be a legacy, a signature from the original structure that formed it. Let's summarize. We have two dizzying clues. First, the incredible mathematical harmony between our universe's mass and its size. Second, the potential existence of an overall spin, the exact kind of information a black hole is able to remember. So what does it all mean? This theory hints at a universe with a much different structure than we imagine, perhaps one that is nested, layer within layer. Einstein's math suggests the singularity at a black hole's center might not be an end, but a bridge. Perhaps our Big Bang was actually a new beginning, born from a black hole inside another parent universe. This would mean black holes aren't just cosmic endings, but the seeds of new creation, a kind of cosmic recycling system. Of course, as Neil deGrasse Tyson emphasizes, this is not yet a proven fact. This is a journey to the very frontiers of science. The data on galaxy rotation still needs to be confirmed across billions of galaxies, and perhaps it's all just the result of a physical law we don't yet understand. But whatever the outcome, this theory teaches us one thing: the universe can be stranger, more complex, and more magnificent than even our wildest dreams. Whether we are inside a black hole or not won't change our lives tomorrow morning. But this thought elevates the awe and curiosity we feel when we look at the sky to a whole new dimension. This mind-boggling order, these precise mathematical balances, these colossal structures, they all remind us just how vast and complex a design we are part of. They make us ponder the greatness, the artistry, and the infinite knowledge behind this magnificent order we observe. So, what do you think? How does this theory make you feel in the face of the universe's vastness? Share your thoughts with us in the comments. And for more journeys like this, exploring the secrets of the universe in the light of science, don't forget to subscribe to our channel. See you in the next episode. Keep wondering and keep contemplating.